right, hi guys. So right now we're going to go over the second type of factoring that we're going to learn, which is called DOTS factoring. So I'm going to first explain what DOTS stands for, and then we'll go back at the top and talk about our first 10 perfect squares. But I'm going to go right here and just fill in that DOTS stands for difference of two squares. Now, when we say squares, what we mean are perfect squares, meaning numbers that can be written as two of the same number, the product of two of the same numbers. So for example, 25 is considered a perfect square because I can write that as 5 times 5, okay? So that means that 25 is a perfect square. So let's just go back up at the top and we're going to identify our first 10 perfect squares starting with 1. So there's actually an easy way to do this that you don't need to memorize anything. I'll show you the method that we're going to use. So I just want to start off by doing 1 squared. So 1 squared means that we are doing 1 times 1, and 1 times 1 is 1, okay? All right, now we're going to do 2 squared. So 2 squared means I'm doing 2 times 2, and 2 times 2 is 4. Okay, 3 squared, 3 times 3, 9. I'm just going to keep doing this until I get up to 10, okay? So 4 squared is 16. 5 squared, 5 times 5 is 25. 6 squared, 6 times 6 is 36. 7 squared, 7 times 7 is 49. 8 squared, 8 times 8 is 64. 9 squared, which is 9 times 9, is 81. And lastly, 10 squared, which is 10 times 10, is 100. So the numbers that we have right now on the bottom, so these guys here, these are our perfect squares, okay? So all of these numbers can be written as the product of two numbers that are exactly the same, okay? So for example, 49 can be written as 7 times 7, okay? So we say that the square root of 49 is equal to 7, okay? Now, if you're looking at your calculator, I don't have my calculator on my iPad to show you a picture of, but what you would hit on the TI calculators, and again, you can download a TI calculator to use on your phone or your computer off of the website. You're going to do second, and then you're going to hit the button that says x squared, and then on your screen it should come up with the square root symbol, and then you're just going to type whatever number in. So let's say you were going to type in the square root of 49, the calculator would spit out 7, okay? So those are the steps that are used for the calculator, okay? All right, so now over here, we're actually talking about factoring using this method. So how do I know when I'm using dots? So the way that you would know is that you would have two perfect squares, okay? So here we have a squared and b squared, and then the operation in the middle is going to be subtraction, because subtraction means that it's the same thing as saying the difference of two things. So difference and subtraction mean the same thing, okay? And then here, a squared and b squared are perfect squares, okay? So I think when we see an example, it'll make a little bit more sense. I hope it does. Okay, so we're going to start off number 1. We're going to factor x squared minus 16. So the first thing you're always going to do on a question like this is ask yourself, is this problem a difference of two squares? And the answer here is yes, because x squared is a perfect square and 16 is a perfect square. Okay, if you go back up to your list at the top, you can see right here, boing, there's 16. So what I would actually always do is at the top of a sheet or any practice you're doing is I would write this list out so that you have it in front of you, and I would do it just the way that we did it up here, just going 1 squared, 2 squared, 3 squared. You don't need to sit and memorize it, okay? All right, so we know that this is going to be dots, okay? So now what we're going to do, over here where I wrote math work, so the square root of x squared is equal to x, okay? And then the square root of 16 is equal to 4, okay? And again, to type that in your calculator, you would just hit second x squared, and then this would pop up. You'd put in 16, and the calculator would spit out 4, okay? But what this means, the square root of 16 equaling 4, what that actually means, just so you understand, is that I can write 16 as 4 times 4, okay? So now that we've identified these guys over here, okay, we go back to our problem, and we always start the same way with a double bubble, okay? Now, since we had an x squared in the beginning of our problem, we are going to put the x in the front of each bubble, okay? Now, the 16 is in the back, so we're going to take that 4 and put it in the back of each bubble. And now you need to remember that your signs always go like this, 1 plus and 1 minus, okay? And that, this guy right here, boing, this is your answer, okay? And if you were to actually multiply this back out, you would end up with x squared minus 16, okay? So that might be a little tricky right now, but we're going to keep practicing, and hopefully by the end you feel more comfortable with it. So on the next page, I started off at the top by listing the steps for factoring difference of 2 squares. So you want to see, is it 2 perfect squares with subtraction? That's supposed to be a little asterisk. Then you do your double bubble, you find the square root of each one, and then just one is plus, one is minus, okay? So let's take a look at number 2. So y squared minus 100. So the square root of y squared is equal to y, and the square root of 100 is equal to 10. Okay, so we go back to our problem, and we do our double bubble, and we put the y's in the front because the y squared came first. And we put the 10s in the back, 1 plus and 1 minus. This is a parentheses, okay? So this guy right here, this is your answer, okay? All right, good. Let's go to the next one. So 81 minus x squared. So the square root of 81 is equal to 9. And the square root of x squared is equal to x. So now we go over here and do our double bubble. So now when we're putting the values into our double bubble, notice that on this problem, the number actually came first. So that means I'm going to put the 9 in the front of each bubble. And since the x came second, I'm going to put the x in the back of each bubble. And one guy will be plus, and one guy will be minus. Okay? All right, let's keep going. Number 4. So the square root of 16 is 4. The square root of x squared is x. Okay, so now we do our double bubble. And again here, the 16 came first, so that means that we're going to put the 4 first in the front of each bubble. And then the x squared came second, so we're going to put the x in the back of each bubble. 1 plus, 1 minus. Okay? All right, good. Okay, the next one. So now this one looks a little different because Now we have 9x squared minus 1. So now you have a number and a variable together in one piece, okay? But if you notice, 9 and x squared are both perfect squares. So if I mush them together like that, it still is a perfect square. So let me show you what I mean by that. So if I want to take the square root of 9x squared, the square root of 9 is 3, and the square root of x squared is x. So the square root of 9x squared is just 3x. You just put them together. The square root of 1 is equal to 1. Okay? Go back over here. Double bubble. 3x in the front of each bubble, and 1 in the back of each bubble. 1 plus and 1 minus. There you go. That's your answer. Okay? So even if it looks a little bit more complicated or a little bit more confusing, it's still the same steps. As long as you follow the same steps, you'll be fine. Okay? All right, and let's do this last one here. So now this one, it has two of them that look the way the 9x squared had looked. So the square root of 4x squared is 2x. The square root of 4 is 2. And the square root of x squared is x. Then the square root of 25y squared is 5y, because the square root of 25 is 5, and the square root of y squared is y. So then over here, when we do our double bubble, we put 2x in the front of each bubble, 5y in the back of each bubble, 1 plus and 1 minus. And there you go. So I know that looks a little bit more complicated than the ones we started off with, but again, the steps are exactly the same. I didn't change my steps as I was going through these problems. They may have looked a little bit different or a little bit more complicated, but it didn't change the actual procedure that we were using, okay? All right, so now we're going to talk about perfect square variables, and I'm going to give you some examples to show you what I mean by that. So something that would be a perfect square variable, you've actually already seen, would be x squared, okay? Another example of a perfect square variable would be x to the 4th. The next one would be x to the 6th, and then x to the 8th, x to the 10th, x to the 12th, x to the 14th, x to the 16th, I'm hoping you're seeing a pattern, x to the 18th, and x to the 20th. So I'm hoping that you see the pattern that all of these x's are being raised to even numbers. Okay, none of these are odd numbers, it's all even numbers. So here, any variable with an even exponent is a perfect square. Okay, so anytime you have any letter raised to an even exponent, it will always be a perfect square. Don't worry about an odd exponent. We're not going to be doing any of those. So now let me show you how it works. So now down here, if I were to take the square root, now we already did this. The square root of x squared is equal to x. Okay, and remember that's really x to the 1st. That has the invisible 1. So now if I was going to take the square root of x to the 4th, I would get x squared. If I were to take the square root of x to the 6th, I would get x cubed. If I were to take the square root of x to the 8th, I'd get x to the 4th. I am hoping that you're seeing a pattern here. So the square root of x to the 10th is x to the 5th. So what the pattern is that is appearing is that when I take the square root of a variable to an even exponent, all I need to do is take that exponent and divide it by 2. Okay? So when you're doing this with a variable to an even exponent, you divide the exponent by 2. Okay? And that's all you need to remember for those types of problems. And we're going to practice that now on the next page. Okay. Now again, the procedure that we've been doing this whole time is not going to change. We're still doing the exact same steps. It's just going to look, the problem looks a little bit different. So now number 7, x to the 4th minus 4. So now it's not x squared anymore, it's x to the 4th. So if I want to take the square root of x to the 4th, we get x squared. Because if we divide our exponent by 2, we get 2. Okay, and then the square root of 4 is also 2. So our answer here, oops, we put the x squared in the front of each bubble, the 2 in the back of each bubble, 1 plus, and 1 minus. Okay? All right, so now let's look at the next one. X to the 6th minus 25. So if we take the square root of x to the 6th, we get x cubed. We're just dividing the exponent by 2. And when we take the square root of 25, we get 5. Okay, so now I'm going to go over here, do our double bubble. So the x to the 6th came first, so that means x cubed is going in the front of each bubble. The 25 came last, so the 5 goes in the back of each bubble. 1 plus and 1 minus. Okay? All right, just a few more. Just going to keep practicing the same thing. All right, so 100 minus x to the 10th. So the square root of 100 is 10. And the square root of x to the 10th is x to the 5th. Because remember, we just divide the exponent by 2. Okay, so we go over here and do our double bubble. And the number came first, so we're going to put the 10 in the front of each bubble. And the x to the 10th came second, so we're going to put the x to the 5th in the back of each bubble. 1 plus and 1 minus. Okay? All right. You're doing great. Okay? All right. Let's look at number, what is this? Number 10, I think. Can't see the number. Yep, number 10. Okay. So 4x to the 4th minus 9. All right. So the square root of 4x to the 4th is equal to 2x squared, because the square root of 4 is 2, and the square root of x to the 4th is x squared. Now the square root of 9 is equal to 3. Okay, so we go over here and do our double bubble. And now in the front of each bubble, we get 2x squared. And in the back of each bubble, we get our 3, 1 plus, and 1 minus. Okay? Oops, that's not what I had to do. Okay, all right, one more, and then we're all done. So, number 11, 16x to the 12th minus 121. All right, so the square root of 16x to the 12th is going to be 4x to the 6th, because the square root of 16 is 4, and the square root of x to the 12th is x to the 6th. And the square root of 121 is 11. So we do our double bubble, and we put 4x to the 6th in the front of each bubble, and we put 11 in the back of each bubble, 1 plus and 1 minus. Okay? And that's it. That's how you factor a difference of two perfect squares. So I'm hoping that this makes some sense. If it doesn't, send me a remind, send me an email. We can meet for a video conference for a Zoom, and we will get this all figured out. But thank you for watching, and I will talk to you guys later. Bye.